Hello, I'm Mr. Franklin, and today we are going to take a look at measurement. While on the surface that topic may seem simple, I can assure you it's not. But it is essential for us to be able to communicate our findings in an experiment, how we design an experiment, and how we interact and work with the world around us. So our essential question for these notes is, what is truth, and how do we communicate truth in science? So here are some questions that by the end of this video you should be able to answer. Truth. We talk about it all the time in the media and in our homes, hopefully, and in our classes, certainly science. Truth can be defined as, if you Google it and look it up in the dictionary, it can be defined as the body of real things, events, and facts. If you look up, I looked up fact and actuality as a synonym, and I got the definition that it's something that is neither derivative or independent but exists necessarily, which that definition is really important to us, and I'll come back to it. A truth can also be a judgment, proposition, or idea that is true or is accepted as true. I think the best way, especially with that second definition, to talk about truth is just what is. In the study of philosophy and science, we come to realize that there's two different types of truth that we're going to be talking about. The first one is objective truth. So an objective truth is something that is true. It is independent of the observer or the subject doing the viewing. So what does this mean? This one way to look at it is true whether we like it, whether we know it or believe it. It's dependent on the object itself. So for example, the sun has an effective surface temperature of 5,770 Kelvin. Before this video you may not have known that, but that doesn't change the fact that it is true. We may not like that that's true, but it is still true. It is an objective truth. It does not have to deal with who we are as the observer. It is independent of the observer. Subjective truth. It's something that is true, but it is dependent on the observer or the subject doing the viewing. So, for example, you like flying airplanes, I don't. That's totally dependent upon who the observer is. Another example is, it's 95 degrees Fahrenheit outside, and you think it's hot outside, but I don't. Totally dependent upon the viewer. So those are some basic examples of subjective truth. So, test yourself. Which statement is objective? Which statement is subjective? So number one, she ran really fast. Objective or subjective? We could probably argue for both of them, but she ran really fast. Fast is a comparison towards something else. What if I can run faster than that person? Well, then that really fast may not be fast to me. So it's really dependent upon the observer there. Number two, he ran 40 yards in 4.7 seconds. Is that objective or subjective? Does it depend on who's watching him or recorded that information? In a perfect world, we'd say, no, that's what he ran. So that would be an objective statement. Yes, we could argue that, okay, maybe they didn't time it exactly correct, or some things like that, but that's not what we're talking about right now. Number three, the Earth orbits the Sun. Objective or subjective? Okay, we would say that's objective. Because whether you believe that to be true or not, we could say that's true. We could say that's an objective statement. Number four, the Sun orbits the Earth. That is, even though from antiquity there were big arguments and some people proved that the Sun is not the center of the universe, the statement, the Sun orbits the Earth, is an objective statement. Now the question is that true or not? So what we find out if we read this note is that actually 3 and 4 are both not exactly true, but they are both objective statements, because we could measure it and we could figure that out. The sun and earth orbit each other in real life. The sun just doesn't move as much as the earth. So that is probably the most objective of 3, 4, and our little note there. Number 5, objective or subjective? Mr. Franklin is tall. Write down what you think in your notes and I'll ask you in class. Why is this important? Because experiment is the test of all knowledge. It's a quote from Dr. Richard Feynman, famous physicist. And when we experiment, we are usually measuring something, and quantitative data is objective. It is the most desirable type of data, in part because I can repeat it, I can test it again, and I can test it over and over and over, and the outcome should be the same. Qualitative data is often dependent on the observer, and it can be objective or subjective, but we have to be really careful about qualitative data because it's usually in comparison to something else. Sometimes that is all we have. That's all we can base our observations on, and we have to run with it. So we have to be careful of it. But as soon as we get into qualitative observations, we have to be careful that we are not introducing subjectivity to our experiment. So when we measure something, we are looking for quantitative data. We are looking for the most objective, most neutral observation that we can get. So when we measure, we need to record what we measure, how we measure, and what unit or quantity we measured in. So what does this mean? Length or distance? What's the difference between those two? What do you think? Well, we could measure both of those with something like feet, inches, meters, miles, whatever. There is a fundamental difference between length and distance. If we look at the length of a pencil, when we talk about length, we're talking about that includes every particle across that object, whereas a distance is just how far something moved. We're not talking about the object itself, just how the object moved. These are some things that we use to measure distance. So we could use a tape measure, or meter stick, or rangefinder, or radar. Those can all be used to measure distance. They can also be used to measure length. And because we use the same tool to make those measurements, we use the same unit for our measurements. So for length or distance, the agreed upon unit is the meter. It's given the lowercase letter m, and so here in our picture we have a distance of 10 meters, or we have a pole vaulter with a pole that's 3.2 meters long. The meter is a human-sized quantity. It's about 3.2 feet or 39.4 inches. We use the meter to measure things that fit the human person. You have this mental image when you're thinking centimeters. It's 1/100th of a meter. Then we have our millimeters, which break it into smaller divisions, divides it into 1,000 parts. These are called millimeters, represented with the letters mm, lowercase, both of them, and it means 1/1000th of a meter. So 1 millimeter is 1/1000th of a meter, or in decimal form it would be 0.001 meters. So 1 meter in total is 1,000 millimeters. If we imagined that we took this meter and it was actually one of these little measurements, then 1,000 meters would be equal to 1 kilometer. So we have no way to measure something like that, but when we looked at our lab and looked at distances, we could measure large distances. If you travel to, say, Baja California, Mexico, you're going to see kilometer markers on the road instead of miles. So what about distances that we haven't even talked about yet? What if you looked up at the sky, you look at the stars? How do we measure distances between stars? It's millions upon billions and trillions of miles between them. And so all of this, when we talk about different units, what we're really doing is we're trying to get units that are manageable from a numbers and calculation perspective that we can talk about. So one of the things we do is we use a unit called the light year. A light year is the distance light travels in 1 year. So for example, Alpha Centauri, our closest star, is about 4.27 light years from us. If you were to look at that star, the light you would be seeing took 4.3-ish years to reach us. Well, the sun is also a star. If you look at the sun, which you should never do directly, if you look at the sun, though, the light traveling from the sun took 8 light minutes to get to us. In other words, it took light 8 minutes to travel from the sun to us. So that is all I have for you today, but before you go, you should test yourself. Can you answer these questions? What is an objective truth? What is a subjective truth? What is a unit? What does a meter measure? How large is a meter, kilometer, centimeter, and millimeter? What do these abbreviations M, km, cm, and mm represent? What unit is used to measure vast distances? That's all I have for you today. Thank you, and have a good day.